We have given function, and first we find the domain. Because we have the power, subtraction, multiplication, it means the domain of our y function is all real numbers. Next, to find maximum and minimum, we will use second derivative test. So let's first find the first derivative. Will be the first derivative of x to 4 is the derivative of x to 4 is 4x to third minus the derivative of 2x to third is 2 times 3x square. So first derivative is equal 4x to third minus 6x squared. We have first derivative. Now we have to check when the first derivative y prime is equal 0. If and only if 4x to third minus 6x squared is equal 0. We have to solve this equation. So first I will factor 2x squared. 2x squared. So in parentheses we will have 2x minus 3 equals 0. So left side will be 0 when 2x squared will be 0, or 2x minus 3 will be 0. So we have to solve this equation. So x is equal 0, and from this equation we have x equals 3 over 2. We had two critical values. Next, we have to find the second derivative. It means we have to find the derivative of the first derivative. So y this is equal, derivative of 4x to third is 4 times 3x squared minus 6x squared. Derivative of 6x squared is 6 times 2x. So y this is equal 12x squared minus 12x. Now when we have second derivative, we have to check the value of the second derivative for x equals 0 and 3 over 2. So y this of 0 will be, we have to just replace x by 0, so will be 12 times 0 to second power minus 12 times 0. We see that the second derivative for 0 is equal 0. So we cannot say that is positive number or negative. So for x equals 0, we don't have minimum or maximum. Next, we have to check the value of second derivative for x equals 3 over 2. Y b's of 3 over 2 is equal, we have to replace x by 3 over 2 in our second derivative. So will be 12 times 3 over 2 to second power minus 12 times 3 over 2. So this is equal 12 times 9 over 4 minus 12 with 2 we can reduce, so will be 6 times 3 is 18. This is equal 4 with 12 we can reduce, will be 3. So 3 times 9 is 27 minus 18. This is equal 9. So the second derivative for 3 over 2 is positive. So it means we have minimum for x equal 3 over 2. For x equal 3 over 2, we will have minimum. We have to just find the y coordinates. So y of 3 over 2 will be equal. We have to just replace in our y function x by 3 over 2. So we have 3 over 2 to 4th power minus 2 times 3 over 2 to 3rd power. So this is equal 3 over 2 to 4th power will be 81 over 16 minus 2. 3 to 3rd is 27. 2 to 3rd is 8. So this we can reduce 2 with 8 will be 4. So we have 81 over 16 minus 27 over 4. To subtract the two fractions, we need the same denominator, will be 16. So we have 81 minus 4 times 27 is equal 108. So this is equal 81 minus 108 is negative 27 over 16. So we have our minimum because the second derivative was positive. It means we have minimum point. First coordinate is 3 over 2. The second is negative 27 over 16. This is our minimum. Next, we have to check if our function has inflection points. So we need to set our second derivative to 0. Y is equal to 0 if and only if 12x squared minus 12x equals 0. I will divide every expression by 12, so we will have x squared minus x equals 0. Now we can factor x, so it will be x times x minus 1 equals 0. So the left side will be 0 when x will be 0, or x minus 1 will be 0. So we have to solve this equation. It will be x equals 1. Next, we will draw the graph of our second derivative. We have an x number line. We have quadratic function. The graph will be parabola open up because the coefficient before x squared is positive. And we have root 0, 1, open up. We see this part of our y-base function, our second derivative function is 12x squared minus 12x. This part is above x-axis, so has positive value. This is under, so has negative. This is above, so has positive. So we see when we pass 1, we change sign from positive to negative. When we pass 0, we change sign from negative again to positive. So it means we have two inflection points. Let's calculate the y coordinates. We have x equals 0, so y of 0 will be, we have to go to our y function and replace x by 0. So it will be 0 to 4th power minus 2 times 0 to 3rd power, so this is 0. So our first inflection point is 0, 0, inflection point. And the second is for x equals 1, so y of 1 is equal 1 to 4 minus 2 times 1 to power 3. This is equal 1 minus 2, so this is negative 1. So we have a second inflection point is 1, negative 1. This is our second inflection point. So we solve this problem.